Today we are going to discuss about queues. In ordinary English, a queue is defined as a waiting line, like a line of people waiting to purchase tickets or a line of people waiting to use ATM machine where the first person in the queue is the first person served. Normally, in a queue, people will join from one end and people will have served from the other end. The end where new people join the queue is called rear end, and the end where people will have served is called front end. The first element inserted into the queue is the first element to be removed. For this reason, a queue is sometimes called as FIFO list, first in, first out list. FIFO, FIFO list. Definition of a queue. A queue is an ordered collection of items into which items may be inserted from one end called rear end and items may be deleted from the other end called front end of the queue. Figure shows a queue of students at a library counter where new people join at rear end and the person who entered first will get served first. The person will get served from front of the queue, which is said to be front end. So a queue has two ends, one is front end, the other is rear end. Two primitive operations of a queue are insertion and deletion. Elements can be inserted at rear end and elements can be removed from front end. The process of inserting an element at rear end is said to be Enqueue. The process of removing an element from front end is said to be Dequeue. So, to maintain a queue, we need to have an array and position of front, position of rear. Array, front, rear. So queue is a combination of three fields: array to hold elements of the queue, and front is a variable which holds position of front element, and rear is a variable which holds position of last element. So in here we have declared an array which can store a maximum of 5 elements. If an array can store 5 elements, the position of first element is at location 0, index of first element, and index of last position is 4, 0 to 4. In C, index starts from 0, ends with maximum size -1. So first position is 0, last position is 4. Initially, we have initialized the queue as an empty queue. In an empty queue, front is 0, rear is -1. Just for example, let us assume front is 0, rear is -1. It is an empty queue. Now, we wanted to insert an element. Now, let us assume that we are inserting an element. Insert q comma 10 means we are going to insert a value 10 in the queue. We are going to insert a value 10 in the queue. Normally, as the array is empty, the first element that we are going to insert will be placed at location 0, as the 0 location is vacant. So 0 is placed there. When 0 is placed, see, that is the first element and that is the last element. So position of first element is 0, position of last element is also 0. Front is 0, rear is 0. Again insert one more element. So this is the input array or the input queue. You are going to insert an element. You are going to insert element from rear end and you may delete from front end. So now we are performing insertion only. So we may insert element from rear end. So next location. So next location is at 1 we may insert another element. Suppose you wanted to insert one more element at 2. You are inserting one more element at 3. You are inserting one more element at 4. So first element is inserted at 0, second element is at 1, and third element is at position 2, fourth element is at position 3, and fifth element is at position 4. During the insertion, what happens to front and rear? See, initially when the queue is empty, front is 0, rear is -1. And when you are going to insert another element, what you are doing is rear plus 1 and entry of rear is x. So entry means if the name of the array is entry, name of the array is entry. See here, initially front is 0, rear is minus 1. So we perform rear plus 1, that is minus 1 plus 1, which is 0. Then entry of 0 is 10. So 10 is placed at location 0. Next time, when you wanted to insert 20, again rear plus 1. What is rear in the previous case? Rear is 0. So 0 plus 1, which is 1. In the place of rear, that is entry of 1. Entry of rear is x is 20. So entry of 1, because this is array name is entry. So entry of 1 is 20. 20 is placed at location 1. And again you wanted to insert one more element. Again rear plus 1. Rear plus 1. Already rear is 1. 1 plus 1, 0. 1 plus 1, 2. Entry of 2 is your 30. So in the second place, 30 is placed. Again you wanted to insert one more element. Again rear plus 1. Rear is already 2. 2 plus 1, 3. In the third location, you are placing your array. Another element you are placing, that is again rear plus 1. Rear plus 1. Rear is already 3. 3 plus 1, 4. Entry of 3 plus 1 is 4. Entry of 4 is your x, new element 50. Entry of 4. Fourth position is filled with 50. So every time what is happening? Rear plus 1 and entry of rear is x. So you wanted to insert an element, you increase rear value and place new element at rear position. See here, the array is the capacity of array is 5 elements. 5 elements have been filled. Still, you wanted to insert one more element. See here. Here we are trying to insert one more element when we have filled all the 5 elements. Now there is no space in the array because array is a static memory, fixed memory. Here we have selected an array consisting of only 5 elements. We have inserted 5 elements. Now we attempt to insert one more element, but there is no vacancy to store that element because rear already reached its maximum position. Last position is 4. Rear is already reached its maximum position. If you wanted to insert one more element, rear will be increased by 1. Rear becomes 5, but there is no fifth location. So it is not possible to insert one more element. So the array becomes same, the queue remains same, front becomes 0, front remains 0, and rear also remains 4, and all the elements remains same. Instead, it displays an error message that queue overflow, the new element that you are attempting to insert. When queue is full, it's not possible to insert, so it displays an error message. Now see, throughout the diagrams or throughout the sequence of insertions, observe that rear only changing in the first location onwards. Say front is 0, front is 0, next location also front is 0, next also front is 0. So whenever you attempt to insert an element, front remains constant, rear is increasing. See here, initially rear is minus 1, then rear is 0, then rear is 1, rear is 2, rear is 3, rear is 4, etc. So the main operation is rear plus 1 and entry of rear is x. One more thing. So we need to define a queue. Queue is collection of 3 members: array, front, rear. Array to hold elements of the array. Front is a variable which hold position of front element, and rear is a variable which holds position of last element, because it has to maintain two ends, front and rear end. So queue can be defined as a struct queue, which is having entry is name of your array, entry of max queue. What is max queue? 50, or you may say 5. So here in this particular example we have to use 5. Then int front rear, so it is having 3 members: entry, front, rear. Then struct q is a variable, q is a q variable, q is having entry, q is having front, q is having rear. You wanted to use rear, normally q dot rear is q dot rear plus 1, and you wanted to use entry, you have to use q dot entry of q dot rear. So all the members you have to use along with name of the array or name of the structure. Now dequeue. Dequeue means deleting an element from a queue. We can delete elements from front end of the queue. Suppose, for example, let us use the same array, same queue, where queue contains a maximum of 5 elements. We have filled 5 elements. From location 0 to location 4, there are 5 elements. When there are 5 elements and queue is nothing but collection of 3 fields or 3 members, it is a structure: entry, array, it is an array, entry, it is having front and it is having rear. It is having 3 fields or 3 members: entry, front, rear. Entry is an array which holds all the elements of the array. Front holds position of first element, rear holds position of last element. In this particular queue, there are 5 elements. Front is pointing to 0, rear is pointing to 4. So front is 0, rear is 4. Then delete. Try to delete an element. We can delete first element or we can delete an element from front end. So front is at location 0. So 10. 0 is having 10. 10 is removed. Once you remove 10, front pointing to next location. Now front is 1, rear is 4. Again you wanted to delete one more element. Front element will be removed. Front is at 1. Front element is 20. 20 is removed. So you will get this queue. Front is 2, rear is 4. Again you wanted to remove one more element. So front element can be removed. Front is 2, second element is 30. So 30 is removed. So you will get this queue. Front is 3, rear is 4. Again you wanted to delete one more element. Apply delete. So when you delete one more element, here there are 2 elements. The first element is, or front element is at location 3. 3a is containing 40, that element will be removed. Now front is 4, rear is 4. Again you wanted to delete one more element. There is only one element. That element is the first element, that element is the last element. Front is 5 and rear is 4. See, that element is also removed. Front is increased. Front is 5, rear is 4. Then you wanted to delete one more element. So when there are no elements, it is not possible to remove any element. So it remains as it is. Instead, it displays an error message. Error queue underflow. Error queue underflow. See here, while deletion of elements, observe that only front is changing, rear is constant. Initially, see, when there are 5 elements in the queue, front is 0, rear is 4. When after deleting first element, front is increasing but rear is constant, rear is 4. Then delete one more element, front is 2, rear is 4. See, everywhere while deletion, rear is same, rear remains as same and front is increasing by 1. So every time you wanted to delete an element, these two statements we are going to execute. X is entry of rear and front is front plus 1. Suppose here, see, in this example, when you try to delete an element, what happens? X is entry of rear, entry of front, entry of front. So what is entry? This array. Array of front. Front is 0. Entry of 0. X is entry of front. Entry of 0. Entry of 0 is 10. 10 is placed in X. If you wanted to use this value of the value that is deleted from the queue, you can use for X. So X is the value that is deleted from the queue. So Then front is front plus 1. Front is front plus 1. So front is already 0, 0 plus 1, 1. See here, after deleting 10, front moves to next location, front is 1. Again you wanted to delete, see, this is the input queue and this is the output queue. So again, X is entry of front, entry of front. What is front? Front is 1. Entry of front, entry of 1. Entry of 1 is 20. 20 is removed. Then front is increased by 1. Front is front plus 1. 1 plus 1. 2. See here, front is 2, rear is 4. So rear is constant everywhere. You delete an element, only front is increasing. Front element is going to be removed, front is increased, and we are not changing the value of rear. Rear remains constant during deletion. Front remains constant during insertion. We have observed in the previous case. While insertion, front remains constant. While removing, rear remains constant. See here, once you delete all the elements, front is 5, rear is 4. Front is greater than rear. Front is greater than rear. So front is greater than rear means Q empty. You wanted to check whether Q is empty or not. If you have to check whether front is greater than rear. If front is greater than rear, Q is empty. See the first figure in the insertion. We have declared an empty Q where front is 0, rear is minus 1. Still there also front is greater than rear. When front happens to be greater than rear, you can say that Q is empty. So here, then the main instructions to delete element from a queue is X is entry of front, entry of front, and front is front plus 1. Let me explain the function to insert an element into a queue. Inserting an element into a queue is said to be Enqueue operation. We can insert an element from rear end into the queue. So here there is a function insert q comma x, which indicates that we are going to insert value x in q. What is q? Q is a structure which is having array, front and rear. Front is a variable which holds position of front element. Rear is a variable which holds position of rear element or last element. And array is a variable on array which holds all the elements of the queue. So queue is a structure of 3 elements. So queue type, queue. What is queue? Queue contains array, front, rear. Then we are trying to insert x into the queue at rear end. While insertion, we have to check, is queue full? If queue is full, it is not possible to insert element. If queue is not full, we can insert element. That is, we increase rear and we place element at rear location. Then to check whether queue is full or not. What is queue full? If rear is already reached its maximum position, then it is not possible to insert element. So queue full condition. If rear is equivalent to max q minus 1, if an element is already placed at location 4, then it is not possible to insert one more element. So we have to check, is rear already reached the maximum position of the array? No. As it is not reached the maximum position, you can insert an element there by increasing rear by 1 and placing element in the rear position. Here rear and entry are members of the queue. We have to use q array. Q rear is q rear plus 1. Q entry of q rear is x, where rear and entry are members of queue. So this is a queue. Queue contains array name is entry, Q entry, Q front, Q. You wanted to use entry, Q entry, because it is taken as a pointer. So it is a structure that to a pointer. The members of the structure, when it is used as a pointer, we use Q arrow entry, Q arrow rear, Q arrow front, like this. So whenever you wanted to use entry, Q arrow entry. Whenever you wanted to use rear, Q arrow rear. Whenever you wanted to use front, Q arrow front. We need to use rear is rear plus 1 and entry of rear is x. Q rear is Q rear plus 1. Q entry, Q entry of Q rear is x. See here, if this is the input Q, when Q contains two elements, front is at location 0, rear is at location 1. Sorry, front is 0, rear is 1. This is array entry. So Q is a combination of three fields: entry, front, rear. Now we are trying to insert an element. Insert Q comma 30. In the Q, we are trying to insert element 30. So X is 30. X is 30. I'm using a Q here. I'm using 30. So these are actual parameters. These actual parameters are placed in again these formal parameters. Here Q is passed as a reference parameter because we wanted to modify the Q by calling the function. So the parameter is passed as a reference parameter. If you pass reference parameter, whatever the modifications that are performed inside the function automatically will come out of the main function also. So to modify Q, you need to pass it as a reference parameter. See here 30 is placed here. How? Rear is rear plus 1. Rear is rear plus 1. Rear is already 1. 1 plus 1, 2. Entry of 2 is 30. So entry of 2 is 30. So 30 is inserted here. In this fashion, we insert an element. So the main instructions to insert an element into a queue is rear is rear plus 1, entry of rear is x. Where entry and rear are members of queue, that too queue is pointer to structure. That's why we use q arrow rear is q arrow rear plus 1, q entry of q rear is x. Function to delete an element from a queue. Function to delete an element from a queue is said to be dequeue, deleting an element from front end. You wanted to delete an element from the queue, a front element will be removed. See here, there are four elements. If you delete an element, the element that is pointed by front is going to be removed. Front is 0, rear is 3. You wanted to delete front element, and that is front is a variable which holds position of first element 0. So 10 will be removed. Once you remove 10, automatically front is moving to next location. Front is now 1 and rear is constant 3. During deletion, front is changing, rear is constant. See here, there are four elements. After deleting, the queue contains only three elements. Initially, front is 0, rear is 3. Then after deletion, front is 1, front is increased by 1 and rear is constant, rear is 3 only. See here the instructions. So this is the function to delete an element from queue. Element from queue, that is the front element is going to be removed from queue. This is queue. This is a formal parameter queue. What is queue? Queue is a structure which is having array, entry, front, rear. So queue means it is a structure which is having array. Entry is nothing but array. Array to hold elements. This is array, and there are two more fields which holds position of front and position of rear. So we had a queue. This is queue. Queue is having entry, front, rear. And here it is taken as a pointer because we are calling delete function using reference parameter. Address of queue. Once you pass address reference, automatically the parameter which receives address is said to be a pointer. And now queue is a structure, that to a pointer to structure. The parameters used as q arrow entry, q arrow rear, q arrow front. Instead of q dot entry, q dot rear, q dot front, we use q arrow entry, q arrow rear, q arrow front. The main instructions to delete an element is the front element is going to be removed. Entry of front is x and front is front plus 1. See here, this is the input array. There are 4 elements, front is 0, rear is 3. Okay, you wanted to delete an element, front, then you wanted to delete elements, means these two instructions will get executed. X is equal to entry of front. What is front? 0. Entry of 0. Entry of 0 here is 10. So x is 10. Then front is front plus 1. Front is front plus 1. Front is already 0. 0 plus 1, which becomes 1. See here, front is 1, rear is 3. Rear is constant. We are not changing rear. So here we are removing 10 and front is moving to next location. See here, after deleting an element from front end, the queue contains only 3 elements. Initially it contains 4 elements, now it contains 3 elements. Now again you wanted to delete one more element. 20 will be removed and front will be moved to next location. This becomes front. So like this, you can go on deleting elements, and so that the front is only changing, rear remains constant. During insertion, front is constant. During removal, rear is constant. And once there are no elements in the array, we can't delete an element, right? Let me explain function to display elements of a queue. Here it is a queue. Queue capacity is 5 elements, but 4 elements have been inserted. First element is at location 0, last element is at location 3. So front is 0, rear is 3. So we need to display elements from 0 position to third position, that is from front to rear. From front to rear. The same here it is implemented. For I assign to front, I less than or equal to rear, I plus plus, printf entry of I. So I varies from front to rear. That is, if this is the case, in the example 1, front is 0, rear is 3. So I is 0, I is 1, I is 2, I is 3. So when I is 0, it displays 10. When I is 1, it displays 20. When I is 2, it displays 30. When I is 3, it displays 40. So elements of Q have been displayed. So for I assigned to Q front, I less than or equal to Q rear I plus plus, this printf Q entry of I. I is varying from 0 to 3. It displays 10, 20, 30, 40. Suppose if this is the case, after insertion of all the elements and deletion of 2 elements, front is adjusted to 2 and rear is adjusted to 4. Still the same. We call list queue function. Whenever we call list queue function, what it happens for I assign to q front, I less than or equal to q rear I plus plus. So that is for I assign to front, I less than or equal to rear I plus plus. Printf percentage d entry of I. So I is varying from front to rear. I is front to rear. Front is 2, rear is 4. So I is 2, I is 3, I is 4. When I is 2, 30 is displayed. When I is 3, 40 is displayed. When I is 4, 50 is displayed. So 30, 40, 50, 50 will be displayed. So for I assign to front, I less than or equal to rear I plus plus, where front and rear are members of Q, it is used as Q dot front, Q dot rear and Q dot entry. In a list queue function, we are not modifying, we need not pass reference parameter, we can pass only value parameter. You may call list queue function, list queue of q, which displays. So if you apply list queue function in first case, say example 1, it displays 10, 20, 30, 40. If this is the example 2, where there is a queue contains 3 elements, front is at position 2, rear is at position 4. So from 2 to 4 elements will be displayed. What are the indices from 2 to 4? 2, 3, 4. Position of 2 is 30. Value of position 2 is 30. Value at position 3 is 40. Value at position 4 is 50. So 30, 40, 50 will be displayed. Two examples is taken in here. In both the examples, the elements can be displayed from front position to rear position.